Hello, everyone. Good evening, and welcome to this next edition of the Out of the Box Developer Podcast. So today, I'm very happy to be able to talk about the observability again, and with someone who is really expert on this topic. So that's why I'm happy about it that someone can explain us everything. And also, good evening to the audience who is already here with us. I hope there are some people who are joining us. But before we start the conversation, let's say hello to Luis. Hello, Luis. How are you?
Hello, Sheila. Hello, everyone. I'm very happy to be here. Also, observability for me, I think it's a topic that it's not my specialty, not something that I know very deeply, but I know that it is very important nowadays. We have lots of people vibe coding applications, and I think if we add observability to all kinds of applications, we have more information about what we need to perfect, what we need to see closely, maybe things that we need to correct, and for applications that need to scale, applications of all kinds, I think observability is the thing that we need to do every day on our application. So yeah, I'm very happy to be here. I hope Domenico answers all of our questions, and that's it. I hope you all enjoy the conversation.
Yes, sure. And Igor, hello, Igor. How are you?
Hi, Chilla. Hi, Luis. Hi, everyone that is watching us. Yeah, I agree with Luis. Observability is a subject that is as important as your code, as the architecture. Because in the distributed microservices world that we have these days, in that you have each service performing its own domain separately, if you don't have a way on how to monitor that and figure out what is happening, where are your bottlenecks, the performance of each service, and have that clear picture, alerts, and all of that, you don't know what is going on. Because imagine that you're in a company that has a 20 microservices to perform a single operation. Where is the bottleneck? Where are the transactions going? So observability is something so important and often so much ignored by juniors and even by managers, that having this conversation with a specialist, they will be key. And that's also a subject that resonates a lot with me because I've written a chapter about that on the book. So it will be great to learn from our guest today here. Looking forward to it.
Yeah, sure. So let's welcome him on the stage. Hello, Domenico. Good evening. Nice
Hi,
to have you here.
Domenico.
Hello, everyone. Nice to meet you guys. Nice to be here also.
Great, Domenico. Great to have you here, and we're looking forward to learn about it. And also, even before starting our conversation here, let's say hi to the people that are here interacting with us in the chat. Hi, Samuel. If you're watching us, leave us your hi, your questions here about the subject, about the observability, that we will be able to have your questions answered by Domenico, that is our expert on today here.
Yes, exactly. Maybe Domenico, you can tell us some words about you, how you came to this topic of observability and why you are so excited about it. Or...
Yeah, I mean, as you guys working on technology one important area and key area is always monitoring, right? We, on the old days, called monitoring or logging, and it's more than that, right? When we talk about observability, we are talking about logging, we are talking about traces, we are talking about metrics, right? All these three signals, and they're really important for all the things that you already described, Igor. Like you discover the bottlenecks of your application or about your infrastructure, about your distributed services, I would say. It's really crucial because it's the tracing part is the glue that connect all the dots, right? And that's why it's really important, because you can discover the bottleneck in a specific place on your distributed tracer based on errors, latency, and many other features. And I came to this area, Sheila, replying your question, after actually working many different areas. Like I worked in embedded software development, web development, even in trading stock exchange. That's pretty interesting also. I was invited actually to join to this world, and I found that's pretty exciting. You have a lot of technical challenge, and mainly you lead with technical customers also, right? And other technical developers on using your applications and your solutions like OpenTelemetry in this case.
Mm-hmm. So that sounds very interesting. And I remember that a couple of months ago, we already had a conversation with Thiago Gonzaga about observability. So we touched this topic, but today we are going one step further, and we are looking at observability, OpenTelemetry with sampling. So my first question is to you, Domenico, what is this sampling, and what it means exactly, and why we should use it?
Yes, sampling, if you go to the dictionary or we look for, I think, chemistry, when you talk about sampled, it's part of a main other component, right? It's a sample, it's a part of something. And when we are in observability, I would say that sampling is the practice of recording and exporting statistically representative of all the tracers that you have in a system. Then it's part of the whole tracing. And these parts should be representative because it should represents all the different traces that a system produces. It's just a subset, but it's representing all the use cases that you have on that distributed tracing. Because if you lose some information, for example, if your sampling you doesn't have errors, you may have issues when you have alerts or something like that. Then sampling it's a subset of all the tracers, I would say.
Mm-hmm. And how you make sure that is going to be representative, that you don't leave out data or tracing information, what would be important?
Yeah, that's the important part. When we talk about don't losing representativeness, it's basically you maintain consistent sampling. That's the hardest problem, I would say, and walk through different five failing modes, I would say. You can, for example, in OpenTelemetry, when you are talking about sampling, you have this trace ID ratio sampling, and if you just use the default one, you doesn't have this parent-child relationship granted, which means you can have some traces having gaps inside of it. Then ideally to have this consistent, the parent-child relationship, the correlation should be maintained. And then when you are using a distributed sampling, or actually where you're choosing your sampling, this is a crucial selection. Then you need to grant that the parent-child relationship correlation would still be there. And you have many manners to grant that. For example, you can establish that you are using a tail-based sampling where you listen all the tracers and then you make a decision to sample or not, or drop the sample in the end, which means you can, for example, get a chunk of errors, a chunk of higher latency calls, and etc. This is one use case. Then you can have many ways to grant this, let's say, correlation, and you don't lose the representativeness on sampling. And I think in OpenTelemetry, we call that part of parent-based relationship that you could use on this trace ID sampling. You need to actually use the parent-based correlation to don't lose the representativeness of traces, for example.
Okay. So if anyone has got a questions, then just put it in the chat so that we can forward it to Domenico so that he could answer the questions. So let's go ahead. And maybe I still don't have this understanding exactly. You are doing this sampling, and so usually you have got a lot of data, and with sampling, how can you reduce this? How dramatically can you reduce this cost of infrastructure, cost of gathering data, and this everything cost? So how
Okay. Yeah, I think basically to start actually explaining that, what's the cost? It's huge in some cases, right? I think if you have like a distributed tracing in case of million of calls, it's clear that if you produce traces for all the interactions of all the transactions, this should be stored somewhere else, right? And stored, generated, transmitted through the network, all of these generate costs, right? And not all of this information it's really important. For example, you can have use cases where you have traces. I mean, when you have systems that the majority of transactions or requests are basically health checks, and you don't want to have that all the time, right? You just have a small portion of that. And for that, we have many sampling algorithms like the trace radio based. Basically, you get a percentage or a probability of your traces. You select, like, say, maintain 25% or 50%, then you reduce the number of traces that you ingest, basically, based on this ratio. And this is one way to handle this. And how you decrease costs, it's basically because you're generating 50% less traces, right? And the important thing is, we talked before in your question before, was the representativeness. You still need to maintain the same representativeness of 100%, right? You still need to have the errors, you still need to have the health checks and everything, but into a condensed way, where you still have the important traces there, but into a low granularity, into a lower number of traces or spans in this case.
Okay.
Okay, so just to clarify to our audience and for us, the key benefit on tracing is to reduce the volume of spans that you monitor in your distributed system, right? Instead of having it tracing all the transactions, we would use just these sampling traces to reduce costs, right? So that would be the key benefit on applying this technique, I would say.
It's about sampling, not tracing. Yes, it's the biggest benefit of sampling, in my opinion. But beyond that, I would say that when you have the more representative calls or requests in your system, it's easier to go and analyze that, right? Because then you have only meaningful, or at least the majority of requests that are meaningful for your monitoring purposes there. When you have like this have a number of requests with 100% of sampling, you have many requests that are completely not representative for you. It's not important, right?
Yeah.
And then you're still storing the data that are polluting your analysis. Then besides reducing costs, I think this is the main goal, you can reduce the pollution of your traces. Reducing the pollution speed up the process of analysis also.
Great. So it's much easier to find errors, bottlenecks in the system because you have a reduced sampling. So you also will need to categorize these samplings, right? Because if you're not getting it all, you need to categorize somehow which type you're going to trace, right?
Yep. I mean, I would say that the sampling type, the sampling methodology that you choose, it should be fitting your data. Then it depends on the use case. If you have probably a use case that erroneous requests are more important than other, then you can choose a sampling mechanism that allow you to just have erroneous requests and prune all the others. Of course, this depends on the use case, and OpenTelemetry have all these mechanisms that allow you to have that flexibility. That's the beauty of this part, because then you can adapt, you can choose whatever that fits to you, and then you have like the representative data for your use case. For example, maybe in the distributed tracing, just a portion of that, it's important to maintain errors. Then you can use error sampling just specifically for that, and then you can have all the other distributed traces services around using different samplers. That's a possibility also, and all this kind of correlation, that's important, because then you don't lose the traction of one tracing communicating to another. In this case of the distributed services, you need to maintain the correlation between them to identify the bottlenecks, right? You need to know which servers are calling which servers you have higher latency or more errors or any different actually scenarios, right? And I think that's my answer for that.
Yeah, great.
There are also different kind of samplings.
Yep.
So head-based or tail-based. Or so what is the difference in between, or what do they mean exactly?
Yeah, and even joining with your answer, Domenico, these two that Tila just asked, they have relation on this category that you mentioned, the error sampling, or they are even other thing that you need to add from not only head base and tail base, but let's
No, they
just
are
cover that.
more. I would say that they are subcategories. In the sense, when you apply head sampling, it's the decision it's take on the beginning of the trace. When you use tail based, it's in the end, right? And the main difference here is when it's head based, I would say that's the more easy to implement. It's deterministic, and it's like maybe zero latency overhead. But the bad thing about the head based, you don't, for example, are able to know in the beginning of a trace if some error will cascade downstream the trace, right? Then when you decide to do head based sampling, basically in the root span, for example, you are doing the sampling decision, which means in the first span that you create on the trace, the root trace or the root span, you make the decision not to sample or not the whole trace. Then you lose a little bit of these informations. I have a little bit more further options to allow you to trace based on rules, for example, like you selecting errors or selecting traces based on latency, even on business policies. Probably the best fit is tail-based sampling, where you collect the entire trace, which means you have data to decide if you are pruning that or sampling that. And that's the main difference. And of course, as I said, the tail-based, you need to listen the entire trace, which means you need to have this data stored to make the decision. It's a little bit harder to implement. It's costly also in terms of CPU usage, memory, add more latency. But again, depends on the use case. You cannot allow to use head-based sampling. You should use tail-based sampling. Always depends on the use case, what you want to do. If it's basically just reduce cost without like much smartness or intelligence, head-based is a good option because it's cheap. But in the sense, if you need a little bit more smartness in the process, tail-based is the ideal one. And inside of each one of these, you have the algorithms that implement sampling. If you identify, if you use OpenTelemetry, you know that OpenTelemetry allow you to use many different samplers, sorry. And these as well play a key in the sense how you can reduce costs, how you can actually get your representativeness of traces and transactions in the end.
Okay.
Domenico, I have a question. Can you use different kind of samplers for different kinds of environment? For example, the development or test environment, you have like different samplings from comparing to the production environment, and this makes sense.
Yes, makes sense a lot, I think,
Okay.
because basically, maybe for the dev environment, you don't care much about the correlation. Then, for example, you remember that I talked about this parent-based correlation. That's a key process. Usually, this feature you use the traced radial sampling with the parent-based feature on production, because in production you don't want to miss the correlation, but on development environments you don't care, right? Maybe then you can actually defer how you sample on production and in dev or even in other environments. That's for sure.
Okay, and that's very interesting. But you can have several services in Java, Go, different languages. And how can you ensure consistent sampling between?
That's an interesting question. Thank you, Chila. I would say basically, as everything that we should, let's say we have many different components speaking different dialects or languages, right? How we can establish a pattern? It's usually we have a specification around, right? And we have a specification about trace context that's in the W3C consortium, and they specifies how the tracers communicate between themselves. Then it's like polyglot, I would say. Then doesn't matter the language. If the vendor, or in this case OpenTelemetry, follows a specification that's spread everywhere and used by many vendors, many competitors on this market of observability, then you grant that the consistency of sampling it's across different technologies and different frameworks and different dialects. Basically, this W3C trace context specification dictates how you can communicate, how you can propagate, for example, trace IDs and the correlation between many tracers into headers. We have two main headers. We have trace parent that certifies the trace ID using 56 bits of hexadecimal value. That's the identify the trace ID. That's the unique ID that identifies the trace, the distributed tracing, basically. And this trace ID comes on the trace parent header, which means if all the requests have the same header with the same trace ID, they are part of the same trace, right? And this is specified by this W3C trace context consortium and the specification. And you have as well the trace state that actually allow you to put vendor specific identifiers. In this case of OpenTelemetry, when you have a sampling, you can put like a key that we call OT that's specifically for OpenTelemetry, right? OpenTelemetry comes from OT, and then you can propagate the threshold or probability of sampling, which means in the end of the trace parent, you have the sample flag, meaning if you're sampling or not sampling. This is the key component that you decide in the downstream traces if you're continuing tracing or not. And all of these things, the decision about that, it's in the specification. And The different vendors use that, and the technologies that just respect that. Then it's a polyglot. You can propagate these headers, and with these headers, you can establish the correlation, and you can, for example, use different vendors and see the same thing in different, for example, vendors and different tools.
Mm-hmm.
Yeah, that's the magic of OpenTelemetry, right? Because you have this flexibility. And I would even like to share real quick with you guys here an image from the documentation itself here. That this image represents exactly what we are talking here. Do you really need all of these data? So that's the magic of sampling here, right? Otherwise, like Domenico said, we would be looking into the big piece, and we could even not have a single error here, and you have a lot of data that is not getting what we need. Or would be the right sampling be sufficient? That's really, really interesting how you can tune in the observability, reduce costs, and just apply this intelligence, I would say, in the observability. And even upon your question, Sheila, you asked about the different technologies, and down here it brings some of the SDKs that they have specifically for some language here as well, and many others like.
Yeah, and about that part, SDKs and everything, one interesting thing is OpenTelemetry allow you to do different distinguishes when you need to create traces, right? You can do manual, you can create manually traces and spans, and then you can use the SDKs for that, the programmatic way to actually do tracing, or you can use the contributor distributions, right? For Java, for Python, and many other languages that you have there inside OpenTelemetry, and they allow you to get auto instrumentation out of the box, which means we just use these agents with the OpenTelemetry collector, and you receive out of the box instrumentation from your applications without adding any code. Then you have two capabilities. Actually, some cases you need to actually go a little bit further, and you need to produce your own tracers and your own spans depending on your own use case. Then yes, cases are ideal for that. But basically, you have, and for sure, it's not all the frameworks, right? OpenTelemetry community doesn't want to maintain instrumentation for all the technologies and frameworks that you have around there, right, in the world, but at least the main ones. Then SDK, it's important to even you create your custom tracing and so on, just to clarify that.
Yeah, and we also love things that work out of the box. Since we are in the out of the box developer here, it makes total sense to us here. It's great to have all of these capabilities. Is you when you implement that, you can start moving, and then you, like you just mentioned, you got to personalize that for each scenario, and that's amazing. That's great.
Domenico, you mentioned that these methods they need to make decisions, right?
Yep.
Does this make monitoring slower?
Depends on the kind of decisions that they need to make, right? If it's basically we have the processors doing sampling, but we have also the collector. And one of the sampling methodologies that are inside the collector on OpenTelemetry is the probabilistic sampler. And the probabilistic sampler use basically a decision that it's you have a random value, and you have a threshold that's the probability or the sampling rate that you want to cut down, right? Yeah, you want to have 25 or 50% of sampling. That's the threshold or the probability that we are talking about. And you need to compare this value against something, and usually it's this random value, and this random value can be generated in two ways specified by W3C and OpenTelemetry. Basically, you can derivate the 56-bit from the trace ID and then compare with this probability, and whatever is, I think it's greater than that, this probability will be sampled. If not, it will be dropped. That's the decision. Then it's a cheap decision because basically this algorithm, it's simply applying that decision making. But if you get the rule-based sampling, that's a tail-based sampling, it's a little bit more costly because you need firstly listen the full trace and then make the decision based on span attributes, for example, like error messages or status codes on an HTTP call. When you have this more granularity, this lower granularity, that you need to filter your sample to make the decision of dropping or sampling, then it's costly. But then depends on the implementation and the use case. Could be cheap, but could be costly. It's a variation. It's not a 0 to 1 answer. Unfortunately, it's not like it's cheap or costly. It's both. Could be both.
Yeah, and that one is more costly because that's a tail sampling, right? You need to wait to the whole transaction to end and then determine if you're sampling that or not, right? So, like you
Yeah, and the
mentioned, it depends.
decision, yeah, it depends, and you need to actually decide based on some rules, right? And the rules you specify, depending on the complexity of your rules, the decision-making process will be more. It will actually demand more performance costs, for sure.
Yeah, it's you have tools for each scenarios for every user case. That's amazing.
That's interesting.
Totally right.
I asked about if it turns is lower the monitoring because I think last year I saw a presentation about one of the vendors, right? Talking about using AI in the middle to reduce the traces, to reduce cost. But I think using AI, maybe you have like more false positives or false negatives. I don't know, and maybe slow down more than sampling, I guess. I don't know if you know any vendors that use AI to choose which traces are you using or not.
Not in the decision point, but I know some of them are using to decide which kind of sampling process you can use. For example, if you apply this, let's say the tail sampling instead of the head sampling, and then you have like I would say a window that you are listening tracers, then you have a subset of data where you can make the decision and maybe applying AI to, let's say, depurate a little bit this data and decides if during that period many errors are happening and it should maintain the errors, then it will use the proper sampling to maintain only errors to identify this error, this flaw, and then fix and later on change that. I think this this decision flexibility or this adaptive sampling, it's using AI and it's much better, but it's not using the decision point, it's using the data analysis to actually make the decision, of course, but in the sense that it's analyzing the data and then implementing the proper sampling specified for that scenario. Of course, it's completely used there, but of course, as you mentioned as well, Luis, it's like it's not cheap, right? You need to use this consume some tokens in the backend, in the background, but anyway, it's more smart for sure. And depending on the use case, could be perfect fit for a use case that you have many different scenarios with the time.
And when we talk about this cost reduction, how much are you referring to? You have like use cases with 20%, 30% of cost reduction, maybe?
Yeah.
Interesting.
Basically, it's recommended to use sampling when you have like millions of transactions. If you just have like 1,000 of transactions per day, it's not recommended. Probably it's the best scenario if you just store everything that you traced,
So
because
it's
then
million
you,
per day.
yeah, not per day,
Okay,
but
okay,
per millions of transaction per day. Yes, I don't know
okay.
exactly the number, but it's like in the sense that millions, billions transactions, in the sense that it's a really big environment or really big corporation that have millions of transactions and interactions between different systems. Then it's of course sampling. It's something that will be crucial for this kind of environments. But for small environments, sampling it's an option, of course, but it's not necessary. Maybe it's like depending on the scenario as well, and depending on the size of the company that will use that, the application, and in the end, the number of transactions play a key role here.
Yeah, even the documentation, the number that they says, it's if you generate more than 1,000 traces per second. In that case, would be the recommendation is to sampling. Otherwise, it will not make any difference, I believe.
Exactly.
Yeah. Let's just say a quick hello to Leticia. You're late, but you're here. Hi, Leticia.
I
We're
If you have any
talking.
questions, send it in the chat.
Yeah. We are exploring the world of observability here with a fine tuning on sampling that reduce costs and makes your sampling on observability more focused on what really matters. But as we were just mentioning right now, that's not on every case. It's mostly when you have over 1,000 requests, 1,000 traces per second, right?
yeah.
Great, great. Let's say we also have another question here, Domenico. It says, how do you handle sampling continuity across messaging systems like Kafka? And why this
Hmm.
is interesting? And it's curious. I would like to see how this works with these event-driven architectures.
Yeah, that's it's interesting because it's I mean, messaging systems usually are synchronous, right? And
Yeah.
to maintain the correlation, it's the key component there, right? For example, usually a request starts like, let's say, producing a message, and someone in the other point consumes that message. And this other point can be the same machine, a different data center in the other side of the world, you don't know, right? And actually, to maintain all these kind of connections and dots connected, it's important to propagate what we called, and we talked before, W3C context. The trace parent and the trace state, these two key headers, they are propagated through the messages and also through HTTP requests. And then these bind the dots, and they maintain the correlation between producers and consumers in these messaging systems. They are propagated through the message headers. In the old days, when you don't have message headers, if you used Kafka in the beginning, you just have attributes inside the payload, inside the body.
Mm-hmm.
This was to be stored in the body, in the payload. Of course, it's more costly because you need to check the payload to extract the correlation data and then bind the dots. But nowadays, all the messaging systems have headers, and you can have this correlation inside the message headers, like we do in normal HTTP in the headers.
Exactly.
The same thing for messages. And I think the key component here is this asynchronicity, because the context should be propagated in many kind of different scenarios. For example, interprocess, interthreads, and different even distributed nodes. These different scenarios, the correlation and the context propagation, it's a key component here.
Yeah. So the key thing is that we need to ensure that these correlation IDs, they are being propagated through all of the message systems, right? And yeah, I truly understand when you say about in the old days when you needed to add these parameters within the parent, and then you need to scan into that. You also add cost on that. But if they are on the header, it's much better. I would also use an analogy real quick here. If when your message arrives into Kafka, it's like that your transaction is getting into a boat, and because there's a river that separates each part of the road, right? When the boat reaches the other side of the river, the message is delivered and it's consumed there. Your car needs to keep the plate. The plate is your correlation ID that it's in the headers of your car. If the correlation ID is there, the message will continue being traced and it will continue its path by the consumer that consumes that message. Just wanted to add this analogy that where we were talking here came into my mind, and I think it kind of makes sense.
Yeah, it makes sense.
If anyone has got a question, please put it into the chat so that we can ask Domenico to answer those questions. Or maybe, is there anything, Domenico, that we didn't ask you and you think it's important that we talk about in this session, what we didn't mention so far?
I think we almost covered everything about sampling. I think the important part, the correlation and the different kind of algorithms that we have around sampling, right? The different strategies, tail versus head sampling. I think in terms of sampling, we covered a lot, mostly everything. But I would say that maybe we need to explain a little bit what's consistent sampling. We touched a bit into all the questions in consistency, and I think it's important to understand what's consistent sampling, right? This means that, I mean, first of all, I don't know if everyone in the audience knows what traces and spans, but basically, spans it's the lowest unit of work in tracing or in monitoring, in this case, in observability, sorry. And which means when you have a request, this request, it have a representative of a span. It represents our span. And the trace, it's the overall picture, is the connection of all the spans that are many transactions, many requests, many logs, many database calls, right? Any of this kind of events, we produce a span. Basically, it's the representation of one event, one span. Then traces is the connection between all of these spans. Are actually, it's the full event, right? The distributed event. Then it's traced. And when we talk about consistency between sampling, it's like every span in this distributed tracing makes the same keep drop decision in the end, because this will make the sampling consistent. For example, if some span on the trace make a different decision, you can have gaps. And these gaps will be sensed by the teams that actually maintain that service. They will question why my service is not there if it's part of this distributed service. And the tracer to maintain the consistency means maintain all the components connected, right? All the spans connected. And the consistent decisions making the process in the sampling turns this possible. Then this is important, I think, definition should be settled. The trace should be consistent in the sense that maintains all the components represented there. And this keep drop decision when you should sample, keeping the sampling, or dropping the sampling, it's important.
That's great. Just to illustrate what Domenico showed here, we do have here an image. Let me just share here about the traces. And he just explained here how this looks, right? And we would observe this distribute trace, or as Domenico just explained, the trace between the calls, between the systems, like that, right? We assume that this is time here, and each one triggers each part, and we can, this is not the best example, but it's the one that's here on the documentation. And in let's say on Jaeger, that is also observability backend, you would have how much time each of these calls consumed, from where it went, and each trace will have its own unique ID that goes through every service into the whole service where the trace goes, right? Just to illustrate that, so we can have a visualize here. And the spans you've just explained here, and also how it usually looks into the logs, right? You do have a log here, and this guy here would be the correlation ID, right?
Yeah, that's trace ID.
Yeah.
That's an interesting thing because OpenTelemetry instruments the logs frameworks in a way.
Yes.
When you have OpenTelemetry plug into a system, it doesn't matter which language or which log framework it is. If you have OpenTelemetry there, it will print out the correlation, meaning trace ID and span ID and parent span ID that actually connect all the dots, and it will print it out of the box like your
Yes.
channel. Then
Yes.
it's another good analogy for your joke before. And
Yeah.
it is a nice thing because when you are, like, say, in Kibana and you want to correlate the different logs, this guy here, it will be the ID that you will look for and see all the correlation calls, all the calls that are correlated, all the logs that are connected between different services, right? And when you use OpenTelemetry, these allow you to have that connection on the Kibana log. For
Exactly.
example, I think many of us use Kibana probably in the daily basis on the old days or nowadays, or any other kind of dashboard to see logs. These it's connecting the dots out of the box.
Exactly. You could use this trace ID here, and you will get something like that, and even more detail in Kibana or in Jaeger, or in any other
Grafana.
that use Grafana as well, right? That's it. Any questions from your audience or from you guys? I think that, like I've mentioned in the beginning, these observability, they tend to be neglected. They tend to be ignored by
Neglected.
developers. Neglected. Yeah, thank you, Liz.
We have a question now.
Yeah.
Mateus
Yeah.
is asking, what was the biggest challenge you solved by sampling?
It's more about reduction costs, I would say, in terms of solution. Because, for example, many SaaS environments that use tracing or observability in general should maintain also the data in their systems, right? And to reduce the number of data maintained in the infrastructure, sampling plays a key role there. Then the kind of problem that sampling can solve is basically you have a really good representation of what your services are doing with traces, but with a lower data consumption or ingestion in this case, not consumption but ingestion. Then your costs to maintain that it will be reduced. Then that is the problem-solving solution that we are talking about it here. Sampling doesn't solve anything in the sense that if you have losing some data, sampling will solve that. No, sampling will actually reduce costs, maintaining the representativeness through the traces. And that's all. And the representativeness through the traces will solve the other problems, right? The alerts and all the issues that we may extract from traces.
Yeah. And for companies, cost is everything. You need to have the services working, performing, and get it solved as quick as possible when something happens, and preferably at the lower cost as possible. So this is something that it's very often required by many companies, not in that depth, but it's great to have this knowledge, because for those of you in the audience that are watching and learning with us here with Domenico, the next time you get asked in an interview or in your own job about observability, you know that observability and sampling reduce costs. And when you say reducing costs without losing the observability, the monitoring, and the benefits of it, it shines in the eyes of any manager, any recruiter, and you shows that you know about it, that, and that you get into depth on that. So great advice here. Great session, by the way.
Thanks.
Any questions, guys? It's your time. Domenico is here to answer your questions right now.
Any last questions? Can you use any visualization technique for visualizing somehow this sampling, or for sampling specifically?
Usually, what kind of we can visualize on Jaeger on or Grafana the sampling factor, which means in that span that you're visualizing, the representation, for example, usually the factor represents how much samples was dropped, for example, right? Then you can have this kind of analogy from this sampling factor that comes on span. And basically, when you open the span, you can have, for example, logging, you can have latency, many other metadata information, plus the sampling factor that represents like, okay, I know that these represents, let's say, one of 10 spans, for example, if you are doing 10% of probability of sampling, something like that. That's what sampling factor means. Besides that, when you check the usually the dashboards or the components that have UI, you can see the meaningful tracers there still, right? With this sampling factor, which means how many erroneous spans you get dropped. The sampling factor represents that, but represents also that you have the representativeness of this error. It's there stored into the tracers, which means you can still do debugging. You can still see what's happening in your system.
So I have to tell that today I learned a lot, and I see now that I could learn a lot more about this topic. So it's really quite a huge topic. So for me personally, it was a very interesting conversation.
Thanks.
Yeah, for me too. It was great to get in depth on that, especially because I learned so much writing about that and getting in depth more on it. It was a great to know about of this and the power of OpenTelemetry. It's awesome, great tool, by the way. So we do invite everyone to test with it, try with it, even for your own on your own experiments at home and at your company. Probably if they don't have any observability implemented and they are starting to use distributed systems or microservices, they should consider about it. And if you're the one, that's a good thing. If you would like to be the person that will be moving the observability moment in your company, you will be like Domenico here. And Domenico, how people can reach out to you to ask you or follow you on your social media where you would publish something?
Usually on LinkedIn. I have also my YouTube channel. I can share with you guys.
Yeah.
And basically, these are the medias that I'm posting stuff for nowadays. But soon, probably I will post something on Medium also. But mainly today, it's YouTube and LinkedIn.
Mhm.
Great.
I'll share your LinkedIn page here to everyone in the chat. And I want to thank you, Domenico, for all the teachings today. We have a DevOps team in my company right now that does everything about observability, but we work together as a team to have a better result. And right now, I know that we are facing some cost problem, so I'll share with them everything that I learned here with you, so maybe we can start using these samples there. So thank you so much.
Yeah.
Yeah.
No, it's a pleasure. Thank you very much, guys.
Yes, thank you so much, Domenico, for joining us today. Thank you.
And thank you everyone that is watching us. And see you on the next session.
Don't forget to follow us, follow the channel, and follow Domenico on LinkedIn.
Subscribe and share with your friends if you like this conversation, if you learn about it, and see you in the next one.
Thank
See you in
you.
the next one.
See
See
you.
Take
Thank
you.
you.
care. Thank
Bye.
you.
Bye.